Hey folks, so it's Volodya, and today we will talk about decentralized apps and decentralized storages. And internet was born not only without the identity layer, but internet was born without the persistent storage. So maybe it was no need for this, we don't know, but that's enable a lot of cool features in the internet, because when you have the stateless protocol, it means that you could create a lot of things. You don't care how many hoops, how many routers, and all of the things your request is travel and all of the stuff. So it was a cool idea to be stateless, but the problem is that in some point of time you need to persist data. And it was a lot of solutions. Majority of the solutions actually is the centralized, and you have a server store your data. If something happens with the server, it's your personal problem. So yeah, as you see, it's not so flexible. And the first solution that was actually targeting this problem for sure, it was the peer-to-peer network and peer-to-peer storages. Different kind of the torrents and so on, so people was keen to share the files in a more effective way. And after that came blockchains. For sure, blockchain is one big global state that synchronized, and so it was cool. You have the storage, but the problem that for example, Bitcoin is extremely specialized on the transactions, and with the Ethereum and smart contracts it's a bit better, because smart contract could hold some data, but still the storage is extremely expensive. It's inefficient, and it's have the problem with the privacy, because all this data actually it's the open data, so everybody could go and everybody could see the state of the blockchain. So if you build in some privacy focused decentralized apps, it's not the option. So after that people came with the IPFS. IPFS actually solved the problem that you need to store something in a decentralized way but outside of blockchains. And IPFS for sure it's extremely cheap, so it was quite good companion to the blockchains, that for example you could store the hash from the IPFS to the smart contract and somehow link the big amount of data, and in a more manageable way. And that's how the majority of NFTs, for example, working. So the IPFS is cool. It's let's say content addressable, huge acyclic graph. So it's a duck that store your data in a quite efficient way. So you have this small chunks of data that are self-addressable. So the address of the data portion in IPFS is actually the hash of the data. We could have the separate discussion why it's not so efficient, but it was the big step forward, and IPFS empower a lot of decentralized apps and a lot of cool ideas like IPVM and all other things that right now happening in a decentralized world. So the IPFS and especially the IPLD that are quite abstract from the IPFS is really the big step in a decentralized data. But IPFS struggle from multiple problems. One problem is already mentioned in blockchains, that it's privacy. So all the data in IPFS is globally available. It's public data. So if you want to store something only for yourself, only one option is the encryption, and your encryption should be post-quantum, because the target of IPFS store the data forever, and post-quantum computing could actually break all our security. But another problem with the IPFS that it's immutable, it's super cool, but it's the immutability sometimes create the problems. But the main problem of the IPFS that you don't have the incentive of the user of the network to store your data. So you couldn't be sure that your data actually will be stored for a long time. store your data, it's not go away. You could not convince other nodes to actually keep your data, and vice versa. It's a big problem for the GDPR and privacy folks that you could not easily delete the data from the decentralized systems. You could not easily delete the data from the IPFS, and the IPFS lacked the permission layer. So, as you see, a lot of challenges, and different projects try to improve IPFS in a different ways. For example, we have a lot of storages that try to create the economic incentives for the storing the data. So we have a FileCoin, we have a lot of things that actually you pay for storing the data, and you have this models where you have a proof of storage that you, for example, have the file, and from time to time you ask the peers some question, and the answer to this question actually is the hash from the stored file and so on, so that you could make sure that it's stored, and you pay in some internal currency, or maybe you pay in Bitcoin or Ethereum, doesn't matter, but you know, still it's solve the intention or the motivation to store the data, but the privacy is a big question. And for example, if you take a look to the project like Ceramic solves this in a quite effective way. So they build a lead protocol that build a permission layer on top of the IPFS, so you could share the data effectively, you could hide some part of data, but there's still the question, because you need to trust the network to actually store the data, and this data stored in anyway in IPFS, so it's the big question of the security anyway. But you know, with the IPFS we have one, and the blockchain we have one common thing, and it's a big thing of the decentralized app, that all the time we try to build one global USB stick that are absolutely identical. Yeah, so we want to build a global state, and the global state, it's a big stopper, and not always you need the consensus, not always you need the global state, not always you need to have it synchronized everywhere. So for example, we have some networks like the Definity network, that it's an internet computer that have slightly different approach. So it's a relatively cheap blockchain with relatively cheap storage. So you could store something like 5 gigabytes for $20 per month. So it's already good, and it's have the reverse sharing model or reverse fee model, that it's not the users of the application pay, it's the application pay itself. So be careful with it, but actually what they made, they have the clusters of the machines, and the cluster of the machine, the internet computer, keep the state, but this state is not the global state, it's the global state for the subnetwork. And it's allowed to do a lot of interesting things, and in terms of storage, it's a lot of make the things easier, but you know, still we struggle with the privacy. With the Definity, you have actually the possibility to store full encrypted data in a blockchain, so it's solve your privacy, but turn to the problem of the retrieval recall, and actually the extra computation time to decrypt the things, and then the user should care about the private keys and all other things. So it's still not perfect, and how we could effectively solve this problem, it's a good question, but you know, we need to take a look to our use case of our decentralized apps. And if you talk about the user-centric apps, quite often user have his personal data. A user could share some personal data with other people, but we don't need a global state. So we could switch to the architectures that have the local fast, offline fast setup with co-local architecture. So I have the video about the co-local architectures on my channel for practically a year. Unfortunately, it was a bit ignored, but I will include the link to the end of this video. So the idea is super simple, that you store all the data locally, and you get super fast apps because they work with the local data, they do not use the network. And in some point, if you want to share the data with others, or you want to collaborate with other people, then you synchronize the portion of your data that you want to share with some kind of network. And the network topologies could be quite different, so it could be peer-to-peer, but we already know that peer-to-peer network is a huge adoption stopper for the people, because people need to take care to run their own nodes, and it could be challenging, it could be tech savvy. That's why more modern projects like Nostr, more modern projects like the decentralized web nodes especially, they choose different network topology. So they go with the relay approach, and relay, it's quite flexible. You could have your local server that could practically live in memory, could be embeddable, and this server have the full sync with the remote servers, and remote servers actually could be hosted somewhere permanently. They all have the same protocol. They could have the different transport layers, so some of them could talk with the TCP, some of them could use HTTP, some of them could use WebSockets, and so on. But the most important, that you have the transport protocol, then you have the protocol of the, let's say, application level that have some security features and all other things. And for example, the DWNs use the relays. So you have the rich client that could talk with the multiple relays, get the data from the multiple relays, so store the data to the multiple relays, and relays not talking to each other. So it's not a peer-to-peer network of the servers. It's more like Sun-like architecture, that you have a client that have ability to talk to the different relays. So you have a client that have a ability to talk to the different servers. You could build the servers in a smarter way that they could synchronize with each other, but the concept of relay, that it's a sweet spot between the centralized server and peer-to-peer network, that the client decide with whom he wants to sync the data, the client decide from whom he wants to take the data, and the DWNs have the permission layer on top that based on the DADs. So the messages in DWNs could be full encrypted, but you will get the penalty of the performance, or they could be in an open format, but to get the data you need to prove that you own your DAD, so it's already quite good permission layer. And DWNs have even more, because they have the concept of the protocols that mix together different kind of roles, permissions, and the actions that you could do with the data. So you could design the application that will give the access to some particular role. If user have this role, user will get this data. So, and it's this co-local architecture, because when you have no global state, when you have the still ability to sync with the relay and share the data that other people could read selectively, and the most important, that you have a permission layer on top, you could build quite different and quite complex topologies. And it's still decentralized, but what you could do, you could build the local fast apps, and these apps will no need anything, so they could have their own permission and persistent layer, or they could directly talk with some remote DWN nodes. and synchronize the data there. So when you go with the full local setup, then it's blindingly fast. When you go with the co-local setup that they go to the network, they will be much slower, but it's look like the decentralized web nodes, it's a sweet spot that allows you to build the decentralized apps and have the persistent layer that are flexible to configure and have the huge potential to actually bring the privacy and personal data to the decentralized world. So I encourage you to read the spec, join the TBD Discord channel to learn a bit more. And actually, that was all that I was keen to share with you today. And see you in my next videos. Subscribe to our channel and choose